Right, we've got the International A-Level October 2021 question 10. There's a trig identity we've got to do, and it's really about this curve. We've got to sketch up here and find in this area. The question's all about that, but we've got to do a bit of trig first. So here we go. First about the question: 1 plus 2 cos 2x all squared, something plus something else times cos 2x, and then we've got r cos 4x. If we square this out, we get the 1, then we'll have 1 times 2 cos x doubled, of course, and then the last term, 2 cos 2x all squared, which is 4 cos squared 2x. But they want it in this form. We've got the number, the p, we've got the 4 cos 2x, so that looks like that as well. So the first part is looking like what we want, but we want this to be cos 4x rather than cos squared 2x. Now in the formula book, you get the compound angle formula for cos, plus and minus there, and minus and plus, of course. So if I do the top one and replace the b with another a, I get cos minus sine, or cos squared minus sine squared. I could change that sine squared into 1 minus cos squared, and we get this familiar double angle formula for cos then. Now the a stands for anything. The B is there because it's the next letter in the alphabet, but you can put anything for the A. So I could replace it with a 2x, cos of 2, lots of 2x, and cos squared 2x, which is what I'm after really, because then I've got, that's 2 cos squared 2x here, which is what I want, but I've got cos 4x over here, and that's how I'm going to get the cos 4x in that expression. I could rearrange this so it says cos squared equals, but I'd rather, because I want 4 cos squared 2x, I'm just going to double it all. So I have 2 cos 4x and 4 cos squared 2x minus 2. If I double all this one, and then I've got the 4 cos squared 2x, which is what I want. And then I can write it like this, but just take the 2 over. So I'll replace the 4 cos squared 2x with what I found out down here. And then it means this p is going to be 3. So I've got a 1 and a 2, and then it's in the form that thereafter. So we're finding this area. So we're going to integrate this, which we've turned into this. So we're going to integrate it between 0 and a. And the first thing we're going to do is find out what the a is. I know that where the graph hits the x-axis, in particular where a is, the y is equal to 0. So I've got that bracket squared is 0, which means that the bracket must be 0, so the cos 2x must be minus a half. If I do cos the minus 1 and minus a half, in radians, of course, because I'm integrating, I get 2 pi over 3, which gives me an x value when I halve it of pi over 3, which is that one. That's the first positive one. Now remember when we do cos the minus 1, we can do what the calculator says, or minus it. So I could also have minus 2 pi over 3, giving me x is equal to minus pi over 3 here, which is that value. And then the next one, 4 pi over 3, that'll be this one plus 2 pi, and I have it. I get 2 pi over 3, which is this one. That's going to give me the a. The last one I'd get, of course, by adding 2 pi to this one, which gives me 8 pi over 3, and halving it gives me 4 pi over 3, which is that one. But the a, what I want is 2 pi over 3, so I'm integrating between 0 and 2 pi over 3. Do the integration, 3 becomes 3x, of course. If I differentiate sine 2x, I get 2 cos 2x, but I want 4, so I'm going to have to double it to get 4 there. Cos 4x, well, differentiate sine 4x, I will have 4 sine 4 cos 4x, but I want 2, so I'm going to have to stick a half in front. Put my limits in, 3 lots of 2 pi over 3, 2 sine 2 lots of 2 pi over 3, and a half sine 4 lots of 2 pi over 3. I'm not going to worry about the 0 because all the 3 terms are 0, sine of 0 is 0, so I don't need to worry about the 0. It's just these, what I get when I put 2 pi over 3 in. It's just 2 pi. Sine of 4 pi over 3 is minus root 3 over 2. Sine of 8 pi over 3 is positive root 3 over 2. Now you could I'd put all this lot in your calculator. Don't add the 2 pi though, because you'll get a decimal then. But you can simplify this by just putting this pi in the calculator. I've actually got minus a root 3 here, and then put plus a quarter of root 3. So I'm actually taking away 3/4 of root 3. Like I say, you can simplify it by just putting this behind the calculator and then adding it onto that.